Hello and welcome back to another new video of Basics of Electrical and Electronics Engineering, which is a subject for first year KTU syllabus students. And in this video we are going to discuss average value RMS value of another waveform, that is half wave rectified current waveform. So let us write down the question. Find average value RMS value peak factor form factor of half wave rectified current waveform. So here also, as I just mentioned in the previous video, here also this is a standard waveform which you should know. So the waveform will not be provided in the question paper, you have to draw it by yourself. So let us start. So in the answer, first we are going to draw what is a half wave rectified current waveform. I hope you remember what is a half wave rectifier, which rectifies only the first or positive half cycle of a waveform. Okay. So diode becomes forward biased only when the positive half cycle of the sinusoidal waveform is entering, and this waveform will be passed through the diode. But when this negative half cycle comes, it is being blocked by, because this becomes in the reverse biased condition and this gets blocked. So this is the working of a half wave rectifier, and the output becomes only the positive half cycles. The negative half cycles are eliminated or it is zeroed during the period. Okay, so this is how you have to draw the waveform. As it is a current waveform, we are mentioning here as I and here as omega t, and the maximum value will be equal to Im. So the equation for this curve, this portion will be I is equal to Im sin theta. What about the equation here? Here I value is equal to 0. During this time, I is equal to 0. So these two are the points which you should keep in mind before doing the average value and RMS value. Okay, let's find out what is the average value. What is the equation for finding the average value? Area under the curve for one cycle divided by time period for one cycle. So first you have to identify where is the cycle. So as I mentioned in the previous video, cycle can be identified in two ways. Either you can take the positive cycle and the complete negative cycle where it ends you have to take, or you can also consider where the waveform is being repeated. So here you can see this much portion is being repeated from this point. It is again repeated like this and going like this. Okay, only the positive half cycles are there, the negative half cycles, the values are 0. So where it is being repeated? It is being repeated at 2 pi. The waveform shape is being repeated at 2 pi. So one cycle is from 0 till 2 pi. Okay, now we are going to find the average value. What is the average value? Area under the curve for one cycle, which means you have to find the area from 0 till 2 pi. Here again the waveform is taking two shapes. Here it is sinusoidal, whereas here it is 0. So we are going to split the area into two, area from 0 to pi and area from pi to 2 pi. There are two types of areas here. One is from 0 to pi and the second one is from pi to 2 pi. Area is from pi to 2 pi. Whole divided by 2 pi. Why? Because the time period for one cycle is 2 pi. So this is how you are going to calculate. Now just consider the first case, 0 to pi. We have to calculate it. But the second case, that means from pi to 2 pi, what is the area? The area is 0. So we are going to put here as 0, area as 0 in the second case, but in the first case we are going to find using the method which we did in the previous one. How we have to calculate the area under a sinusoidal waveform? We don't know directly how to find the value, so we are going to use the integration method where we are going to integrate the area of a small strip. Okay, what is the area of a small strip here? You can see I is the length. At every point the length I is changing. So I is the length and d theta is the breadth of the rectangular strip. Now we are going to integrate this one. From where to where we have to integrate? From 0 to pi. Why? Because we are going to find the area from 0 to pi. So integral 0 to pi I d theta plus 0 whole divided by 2 pi. This is the area. So 0 we are going to eliminate and the remaining terms is I d theta. What is I? I is the instantaneous value of current, which is written as Im sin theta. So substituting this Im sin theta d theta we are getting the answer as integral 0 to pi Im sin theta d theta divided by 2 pi. Taking the constants outside, which means Im, 2 pi, all these things are constant, we are taking it outside. So the remaining term becomes Im by 2 pi integral 0 to pi sin theta d theta. Now integrating this one, you will be getting as sin theta. When we are integrating, we will be getting as minus cos pi in the interval 0 to pi. Okay. Now when we are giving the limits, you will be getting the answer as Im by 2 pi in the limits minus cos pi minus minus cos 0. We are substituting the values of each of them and we are getting the answer as 2 Im by 2 pi, where this 2 and 2 will be cancelled out and the remaining answer is I average is equal to Im by pi. Okay. So it is a very easy method. If you have studied properly sinusoidal waveform, then you can easily calculate half wave also. Next we are going to find what is the RMS value of the same waveform. We are going for the general equation, root of area under the curve for one squared curve for one cycle divided by time period for one cycle. So first what we have to do, we have to draw the squared waveform. So this is our actual waveform. We are going to square it. So what will happen if I am squaring this positive curve, another positive curve will be coming, which is not sinusoidal, and if you are squaring 0, 0 itself. So this is our new waveform, this red colored waveform is our new waveform and we are going to find the RMS value using this waveform. So where is the cycle? From where to where is the cycle? Here you can see this is the red waveform. From here to here becomes one cycle. Why? Because it is being repeated at this point 2 pi. Again here we are going to find the area, no? So we are going to divide the area into two portions. One is area from 0 to pi and the second one is from area from pi to 2 pi. Okay. So you will be getting the answer as 0 to pi and here pi to 2 pi whole divided by 2 pi. Root of, what is the area from 0 to pi? What is the area from 0 to pi? We have to calculate it using the integration method. Again, integration method. Why? Because here it is another waveform, we don't know how to find the area under that curve. But for the second portion, you know that the area is 0, so the value becomes 0. Now, how can we calculate this one? This is a small rectangular strip and what is the length of the strip? Is I square. Why? Because it is a squared waveform and here it is d theta. Now we are going to integrate from here till here 0 till pi the area of this small strip. So integral 0 to pi I square d theta divided by 2 pi. Why? Because time period for one cycle is 2 pi here. Now we are going to substitute, instead of I, we are going to substitute as Im sin theta. So you will be getting the equation as integral 0 to pi Im square sin square theta d theta whole divided by 2 pi. Okay. Now you can see here root of Im square divided by 2 pi. These are constants, we can take it outside and the remaining term becomes Im square by 2 pi integral 0 to pi sin square theta d theta. Again the sin square is coming. So sin square means we don't know how to calculate the integral. So we are going to change its form to 1 minus cos 2 theta by 2. Only the form is being changing. We have not integrated it. So Im square by 2 pi integral 0 to pi 1 minus cos 2 theta by 2 d theta. 2 is a constant, we can take it outside. So the remaining terms are Im square divided by 4 pi into, what is the integral of 1? Integral of 1 is pi and integral of cos 2 theta is sin 2 theta by 2. Sin 2 theta by 2. Okay. Now we are going to put the limits. First we are putting the limit pi and secondly we are putting the limit 0 and your equation becomes Im square by 4 pi into pi minus sin 2 pi by 2 minus, when you are putting the limits as 0, all the values become 0. Again here sin 2 pi is 0, so the value only remaining is pi. Pi and pi gets cancelled and the remaining equation is Im by 2 when we are taking it outside from the root. The answer is Im by 2. Next we are going to find what is the peak value, peak factor and form factor. What is the equation for peak factor? Peak value by RMS value. Peak value is Im and RMS value is Im by 2, substituting which you will be getting the answer as 2 itself. Next one is form factor. What is the equation for form factor? RMS value divided by the average value. We found that the RMS value is Im by 2 and the average value is Im by pi, substituting which you are getting the form factor as pi by 2. So that's all how you have to calculate the average value, RMS value, peak factor and form factor of a half wave rectified current waveform. Everybody please do it and study. Thank you very much for listening. Bye.